Okay, 7373 also asking you to work out what's actually going on here. Don't be put off by these here. I've just put some examples in here so I can try and figure out what's going on if I can't figure it out there. So we'll come back to that. Let's have a look at the code. Okay, so I'm creating something new, obviously, and you can see new's been added on to here. So when we say added on in the string sense, in other words, joining on at the end. And the familiar for I loop equals 1 to the length of whichever string variable we're working with. Looking at each character, in this case using the pos function, and checking if that character's in there or not. In this case, or not, because it's equal to naught. So we're saying if each of these characters, and imagine that's why I just created this random string up here, an s new equal to a blank string. It will be tested saying if it's equal to naught, in other words, then it must do this, else it must do that. Okay, so that is true if it's not an uppercase or a lowercase vowel. Okay, in other words, if it's not found in there. Now, the only time it would be found in there is if it's an uppercase or low. So sometimes the equals naught just messes with our mind a bit because we're so used to looking for the greater than naught. So equal to naught means it's not found. Okay. So if it's not found in there, in other words, it's not a, e, I, o, u of any sorts, then do the following. Else, it must add on a hash sign. Okay, now some people will be able to work out already perhaps what's going on. Let's just go through this. Okay, let's say it's a capital A to start off with. That's why I've just done this mixture over here. Capital A, if it's not in there. Okay, but it is in there. Capital A is in there. Okay, so it'll do the second part. In other words, it'll technically replace it'll put in a hash sign. Okay, in the next time it comes around, it looks at the second character, so it looks at the B. Okay, but now this is different. Okay, because B, that's true now, because B isn't in there. So then it adds on the normal character. Okay, let's do it for one more. I think some people will be seeing the pattern, as I say. Now we look at the third character and we say, right, is the E in there? Is it not found in there? No, but it is found in there. Okay, so that's not true. That's not true. Okay, E is going to be found in there, so we'll do the third part. And so what we're essentially doing is, if it's a vowel, we're putting a hash sign. And if it's not, we're just putting the normal character. So for the next one, there's a, pardon me, there's a capital E there, so we would put another hash sign. And now there's a Z, so I would put a Z. And there's a hash sign, so I will put a hash sign there. So it'll end up with that. So essentially what it's doing, or effectively doing, if we go through it, it's creating a new string by effectively replacing any occurrence of vowels, uppercase or lowercase, with hash signs. Okay, and there's another example there for you to have a look at. So, okay, and the only thing possibly just to watch out for is to think of that. And again, if it is a little bit confusing, think of an example. Just write it down on a piece of paper and say, right, let me just write down some random letters, vowels and others and characters, and let's see if this actually ties in with what I'm thinking, or helps me to find a pattern when I'm having thinking there. Right, we're going to move on to 3.8. Right, in 3.8 they're going to ask you to write some little snippets of code, not a whole thing. I'm going to do it in Word. Obviously we do it in Delphi, but just that you could practice and have a look through the way that we go about it, which I think is as important as the solution. The code for input all the variables is done unless otherwise specified. No error checking needs to be done unless specifically asked for. Any code already given, in other words, is already shown. All the necessary variables have been declared, but if you can use others if you wish to. All the code you can write can be entered in the spaces provided. Okay, so there's some blocks here, so they're going to give us an example, and we're going to have a look at them. Well, 3.8.1, I think it's a nice easy one to start with. Write code to display the character was a string called srev. So srev has got some text in it, some characters in it, in reverse. In other words, they mean from the back, I assume, in a memo control called that. Okay, so that's fairly easy if we think about it, because I can use a for loop, but I can use a for loop that goes backwards. Yeah, I can use a for loop that goes backwards. Okay, so I can say for I loop equals the length of the string. So let's just say there were 10 characters down to 1. So now my loop would go 10, 9, 8, 7, 6 instead of the normal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or however many characters there were. And that's just that's the whole string srev, and that's obviously I loop referring to the individual characters within there. Okay, so we can essentially print out a character in reverse. Okay, which also means we can reverse a string, which we've looked at before, but I think it's going to pop up in the next question. So that's the thinking there, is that if I can print it out, I can surely form something that's reversed. I could even compare them, because if I reverse a string and it's equal to the original string, it's what we know as a palindrome. Okay, so if you have the word radar, R-A-D-A-R, and you reverse it, it's exactly the same. Okay, assuming that they're no capital letters in it. That's known as a palindrome, of which there are many examples. Okay, has not been asked though, but I thought I'd share some useless knowledge. Right here, okay, I seem to be able to forecast the future, because the next one is going to be able to ask you to reverse the characters of a string and place it in another string. Okay, so we started with a string called srev, and we went in, let's say it's got A, B, C, D, E, and then we want to put it in another string called snew. So snew starts off being blank, so that's fine, and we want to reverse it. So I'm going to use that same for loop. Okay, and the question here is to get the order right. Okay, because in other words, we say snew is equal to, don't say srev loop plus snew, because that's going to give us a problem. Because let's have a loop at it. Okay, how many characters are in this particular example? 5. So it'll go from 5 down to 1. So that'll start with 5, then it'll become 4. So it'll take the 5th character, then the 4th character, the 3rd character, and each time added on to the end of the string. Okay, so the first time is it'll take the 5th character out, which is the E. Then it'll take the 4th character out, which is the D. Okay, then it'll take the 3rd character out of the string, which is the C. Okay, and then it'll take the 2nd character out, which is the B. Oops, there's it. The B over there, and then it'll take the last character out, which is the A. So that effectively reverses it. Now I could add an if statement which says, right, if snew is equal to srev, then it's a palindrome. Okay, so you can see how these things can just build on each other. Okay, and if they ask you that, you have to say, right, well, I don't know, how do I compare the last one with the first one and the second? No, you just reverse the string, and if they're the same, then it means it's a palindrome. In other words, it's the same word, or sentence for that matter, written forwards and backwards. Okay, and again, just watch out that you get this in order, because if you'd swapped this around, you would have got the wrong thing, because it would replace it at the front every time, which is not what you want. Okay, you'd actually ended up with the same string. So just be careful. It's always a good idea just to just mentally check it with a little string. And in this case, they gave you a nice example, so you could just check your little algorithm. Okay, I would have said many times, and you'll have noticed many times, so we often use string procedures and functions to check if data is valid or not. In other words, does it contain 10 digits in a cell phone number? In this case, they say an email address. When is an email address valid? Well, okay, we're going to use quite a simplified one. We're going to say it must have an @ sign in it, and there can't be any spaces. Okay, so we'll consider it valid if it's got an @ sign and there are no spaces in it. And then they'll say, and then we must just show if it's valid or not via the show message command. Okay. And if you think about validation, it's like lots of things. If you think of passwords and those annoying systems that you go on where everybody's got a different set of rules. Okay, it must contain at least so many characters. It must contain a mixture of uppercase and lowercase. You can do all this now because you know how to work with strings. It must contain at least one special character, or it must contain... Okay, and you say the annoying thing is it changes from place to place. Okay, right. So essentially what we got is we're looking at that. Okay, because it must have, if we think about it, if we think about the code is saying, right, what we've got here is it must contain an @ sign. Okay, but that's a pos function. Okay, that's a pos function. Okay, that's a pos function. Okay, oops, daisy. Something like that. Extra if in there. I just noticed. I was trying to whip it out the way in case before anybody noticed. Okay, I'm missing a bracket there as well then. Okay, I think I've got that right now. Okay, might have too many brackets, but I'm leading you astray here. Okay, that's the first check. Is the pos, look for the space in that thing, and it must be equal to 0. In other words, it mustn't find a space. Okay, greater than 0 would mean it did find a space. Okay, and that's not what we want. Okay, extra bracket in there. Okay, but by contrast, I do want an @ sign to be in there. So I want, and both of these conditions must be true. Not one or the other, both. So this is saying checking no spaces. Check if there's a space in there. If it's equal to 0 means that there isn't a space. And this one's checking this @ sign in there if it is found. We don't care where it's found as long as it's found. Okay, then show message. And then essentially we can just obviously do that for else. Show that it's an invalid email there. Okay, so as soon as I need to check if something's contained in something, think about the pos first. Okay, that's probably your first port of call. Okay, remembering though that it just tells you the position of the first space or thing. But yeah, we weren't concerned about where these things occur. We just didn't want a space, and we just wanted an @ sign. We didn't particularly care where it occurred. Okay, so that's some error checking there. Right, 3.8.3, I've deliberately put some code in there at the bottom because you'll see why in a second. I said write code that checks if a string SDOB contains only 6 digits, nothing else. Okay, so for example, it could be the date of birth, so like 04/12/31 or something like that. Okay, but quite frankly, it doesn't matter as long as it contains 6 digits, nothing else. Uses show message command if the string does not follow these requirements. Okay, so it's got to consist of 6 digits, but only 6 digits. There can't be anything else. Okay, and that might start to sound familiar with another 1 or 2 questions where we looked at where we say, don't just check for 6 digits, because what happens if we have this situation where there are definitely 6 digits? So we take something like 04/12/31, that's fine, that'll check for 6 digits, not a problem. But what happens if there's somebody accidentally put a space at the end, or they accidentally put a $sign? Okay, then if you just check for 6 digits, then that's going to be valid according to your program. Okay, it must only consist of 6 digits. In other words, the length of it must be 6. In other words, there must only be 6 characters, and all 6 characters must be digits. Okay, so I'm going to need a loop that's going to go through it to check for how many digits there are. I'm going to need to check that that's 6. Okay, so I'm going to have some type of count going on. But I also need to check that the length is equal to 6. Okay. Alright, but have a look at this message. They only want you to show a message if it doesn't follow these requirements. In other words, if there are not 6, okay, and there's not the required number of characters in it. Okay, so it's a little bit different before we would have said, and we'll see why in a second there. Okay, and there's my code. Okay, and I left this up because that's standard. Okay, go through the whole string. Okay, set the count equal to 0 because I want to count how many numbers there are or digits there are in that string. It's the length of it. Check each character. If it's in 0 to 9, then increment the count. Okay, right. We are only displaying the message if it is valid. Okay. Sorry, if it's invalid. Okay, I can't read here. Okay. If I was checking for valid, I would have said if count equals 6 and the length equals 6, then it's valid. Okay, but they only want to show a message when it's invalid. So what we need to say is, right, if either of these are a problem, so that's why it's all now. Okay, if they're not 6 digits, or the length is not equal to 6, Okay, so we could deal with an example like we've got up there. Then show message invalid. So the trick here is actually probably in the if state, but that's a little bit different to normal. Okay, because normally we would have checked if it's valid and then we would have just said else invalid.